Welcome. In this video I'm going to show you how you can perform a one sample z-test using Python and my stikpetP library. I'm using Jupyter Lab together with Python version 3.818. This is a test for a single mean, so you can test if the mean is significantly different from a specified value in the population. If you have small sample sizes, perhaps a student t-test is more appropriate. I have separate videos on those. To show you how this can be done, I'll need some example data, so I'll load in pandas, so I can use their read CSV function to load the general social survey data from 2012 adjusted for some example purposes. I actually don't need all the data, I just need one numeric field, so I'm going to be using the age field for that, which has a lot of numbers. However, there are some missing values, so I'm going to remove those. There's also actually a category of 89 or older, so I'm going to replace those with 89, and just to make sure everything is numbers, I use the to numeric. I'll store all of this under scale field. I'll also set a hypothesized mean of the age of 50. Now my library is available by using pip install and then a full link to my GitHub, so don't just only use pip install stikpetP. Once you've installed it, you can import it just as any other library. The function of interest is actually TS, short for test, Z, and then OS for one sample. It takes as input, of course, the data, and you can specify the hypothesized mean. If you don't specify it, the mid-range will be used, and if you want, you can specify the standard deviation from the population. If you don't set it, it will simply use the sample version. So let's take it for a spin. I'll fill out the field and my hypothesized mean, and as a result I get a few different columns as a data frame with the hypothesized mean, the sample mean, the Z statistic, the corresponding two-sided p-value, and the description of the test that was used. In this case, it's the p-value is below 0.05, so in this case we would then say that we reject the null hypothesis and there's a significant result in the population. The average will not be 50. Very likely not be 50. Alright, and that's it. I hope you found this video helpful, and thank you for watching.